Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 and we will be presenting about application of first order differential equation. Okay, before we start, I want to introduce my own teammate. First, we got one Muhammad Azim here, Ang Zenman, Hasan Hadi, which is myself, and Mohnish, anak lelaki Tenagaran. Okay, my name is Hasan Hadi. My matrix number is A82417818. Okay, first let's get through our acknowledgement. So I would like to express my sincere gratitude to everyone who supported me through the complication of this assignment. I'm especially thankful to my mathematics teacher for providing clear guidance and results that helped me to understand the concept of exponential growth and Newton's law of cooling. Their support was instrumental in enabling me to analyze and solve real-world problems involving the differential equation and exponential function. Lastly, I appreciate the encouragement and feedback from my classmates and peers, which motivated me to explore the problem in greater depth and accuracy.
Hi Medium, Assalamualaikum. My name is Wan Muhammad Azim bin Wan Fauzi and my matrix number is AA242005. And for my part, I want to explain about the content or basic theory. For the part A is Newton's law of cooling. Newton's law of cooling describes how an object temperature changes over time when placed in an environment with a different temperature. It states that the rate of cooling is directly proportional to the difference between the object temperature and the surrounding temperature. This means that the greater the temperature difference, the faster the object cools. As the object approaches the ambient temperature, the cooling slows down. Mathematically, this is expressed as T equals to TR plus T naught minus TRE negative KT, where TT is the object temperature at time T, TR is the room temperature, T naught is the initial temperature, and K is a positive constant called the cooling constant. This formula shows that temperature decreases exponentially and never quite reaches the room temperature. Newton's law of cooling applies to both cooling and warming situations and is useful in many fields such as physics, engineering, biology, and daily life. For example, cooling hot soup or estimating the time of death based on body temperature. And for the second one is the part B, exponential growth and decay. Exponential growth and decay describe situations where a quantity changes over time at a rate that is proportional to its current value. This means that as the quantity increases, the rate at which it grows also increases, or in the case of decay, the rate at which it decreases becomes smaller over time. This kind of change is modeled using the exponential function Pt equals to P naught CKT. In this equation, Pt represents the quantity of at time t. P naught is the initial quantity at time 0. E is a mathematical constant approximately equal to 2.718, and K is the rate constant. If K is positive, the quantity grows over time exponential growth. If K is negative, the quantity decreases over time exponential decay. This model is commonly used to describe populations like bacteria, radioactive substances, and financial investment where the change depends on how much is already represented.
Okay, guys, it's me again. So now let's continue about part B. Don't worry, guys, part B is quite easier than part A. And if you listen properly, your engineering maths probably can get A plus. So let's begin now. Firstly, we also need to know what's the question given. In a particular culture, the rate of increase of bacteria is proportional to the number of bacteria, P, present at time hours after the experiment. Given that the number of bacteria at the beginning is 10 power of 6 and after 1 hour is 10 power of 9, find A, the number of bacteria after 5 hours, B, the time taken for the number of bacteria to be 3 times the original. So the first step is same as part A. We form the equation. The first hint is the rate of increase of bacteria is proportional to the number of bacteria. So the rate is that's mean over dt lah. Is proportional to the number of bacteria p means that if you guys learn physics, you know directly proportional lah. So it's a symbol like x. So we can form our equation already. dp over dt, then the x symbol p. Then the x symbol is directly proportional. So the x symbol is equal to k. So we can form the equation is dp over dt equal kp. So same as part A lah, we move from right to the left and the in the same variable, and the different one we bring to the right hand side. So we can get dp over p equal to k dt. After that, we just do the same thing is integrate. So we can get ln p equal to kt plus c. So after that, we move to the step 2. Then the second hint is given already. P equal to 10 power of 6. The question is given like this. Given that the number of bacteria at the beginning is 10 power 6, so the first is 10 power 6, so we just sub P equal to 10 power 6 at our equation. We can get C equal to ln 10 power 6. After that, we just sub the C to our first equation also. So we can get P equal to E power KT times 10 power of 6. Then we move to the third step is the question given that 1 hour equal to 10 power of 9. So also same, we just sub the 10 power of 9 to the P. Then we can get K equal to 6.9078. Then we just sub K to our second equation. We can get P equal to E power 6.9078 T times 10 power of 6. After this, we can start to do the question already. The number of bacteria after 5 hours. So we just sum T equal to 5 to our third equation. We can get P equal to 1.0 times 10 power of 21. And then next we move to the question B. The time taken for the number of bacteria to be 3 times the original. So we just sub the original bacteria times 3, because for the number of bacteria to be 3 times original, so we just times 3, then we can get the time is equal to 0.59 hours. The question, this is important things that before you do the question, you check the question is given hours or minutes. Then if the question is given minutes, so from the first step you need to convert the hours to minutes. If the question given is hours, so the first step you no need to convert hours to minutes, and then convert again lah. So here is the small tips. That's all for me. Thank you. Good afternoon, guys, and my fellow lecturers. My name is Ang. Today, I'm going to talk about problem statement of calculation in this question. So before we start the solution, we need to know what is Newton's law of cooling. So Newton's law of cooling is equal to rate of change of temperature equal to negative K times temperature minus internal temperature. As we know, K is constant. So now we're going to talk about part A. So let's begin now. Firstly, we need to sub the formula into our equation. D temperature over dt equal to negative K bracket T minus TAM bracket. So in order to integrate some things, we need to make sure that the variable are same. The first step we do is bring T minus TAM to left hand side and bring dt to right hand side. After that, since dt over T minus TAM, the variable are same, so we can make integrate. So after integrate, we can get ln T minus TAM equal to negative KT plus C. So this is our first equation. So based on the questions, we can sub internal temperature equal to phi in our equations. So we can get ln T minus 5 equal to negative KT plus C. Okay, based on the questions, we know that a bottle of water with an initial temperature of 25 degrees Celsius is placed in a refrigerator with temperature of 5 degrees Celsius. So here we know that time equal to 0, the initial time, and the temperature is 25. So we just sub inside ln bracket 25 minus 5 equal to negative k times 0 plus c. We can get c equal to ln 20. After that, we just sub c equal to ln 20 to our first equation. Ln t minus 5 equal to negative kt plus c. So we can get t equal to 20 e power negative kt plus 5. After that, we move to our step 3. So let's moving on to the question again. The question given that the temperature of the water is 20 degrees Celsius 10 minutes after in the refrigerator. What will the temperature of the water be after 1 hour? From the question, we know that we need to find the temperature of the water be after 1 hour. So we just sub the hints that he given. T temperature equal to 20 and time equal to 10. 10 is 10 minutes. So we sub inside to the T equal to 20 e power negative kt plus 5. We can get k equal to 0.0288. After that, we sub the k to the second equation also. And lastly, the question given that at what time the temperature of the water reach 6 degrees Celsius. So we just sub T equal to 6. Then we can find that the time is equal to T equal to 104.02 minute.
Okay, back to me, and I want to explain about the filler table. For the fair, as you can see here, the first one, we want to find the temperature after 1 hour 60 minutes and when the temperature will be at 6 Celsius. Second one, initial bacteria counts is 106. After 1 hour, it was 109. And growth is exponential, and we want P in 5 and time to triple. Okay, next, about ideas. Use the Newton law of cooling. Use known data T10 minus 20 Celsius to find the K. Then compute T60 for solve for T when T1 minus C Celsius. So the second one, we want to use the exponential growth model, as you can see there. Next, we want to solve for K using given data and use money to find values at the other time. Next, about learning issues. First, what is Newton's law of cooling? Second is how to manipulate exponential and logs. And how to model population growth with differential equation. And the last one is action plan resolve it. First, review Newton's law of cooling and how to apply it. Want to use the calculator or software to compute exponential and logarithm. Second one, you use calculator or software to compute, as you can see there, the formula, and practice solving exponential equation.
So guys, now is conclusion. After that, we can rest. So in conclusion, Newton's law of cooling provides a reliable and practical model for understanding how the temperature of an object change over the time in response to its environment. So by expressing the cooling or warming process as an exponential function, it captures the natural tendency of temperature to gradually equalize with their surroundings. So this law is not only depends our understanding of thermal behavior, but also has valuable real-world application in science, mostly in engineering and medicines. After that, the rate of temperature change governed by the cooling constant K is crucial in predicting how quickly or slowly this thermal adjustment occurs. So thank you for your guys, my fellow friends and lecturers. This is our team 4. Thank you.